So on Canvas, you'll see there is a section that says, here's all the apple pie videos, but that's actually last year's apple pie videos. I haven't organized this year's apple pie videos altogether. I should do that today. Again, where it says, where was that? Apple pie videos. Those are the ones from last year. It's the same thing, but it might be a little different. I'll put all the ones that we did this year together. And I'll put it in this week. What is this week? The 18th? Or the 11th? The 11th, right? Actually, we want to put that up here. Here we go. We're going to do chapter 3. We'll start the National Park app this week, and then here's a video from last year. There we go. This is actually starting National Park as well. So this week we'll talk chapter 3. You ever wonder what those question marks were for and those explanation points were for in your code? That's what we're going to talk about right now. Okay, why do we use the exclamation point and why do we use the question mark? Okay, we're going to talk about that. And then we do need to jump around a little bit to do the national park. Here we go. We're going to read this here. There's something called table layouts we're going to follow, so we have to jump a little bit. So we're going to read chapter 3 and learn some code for a little while. Then we'll jump to chapter 4 that talks about what we call table layouts. That is the way we're going to build a app. It's a little bit different, but you basically build things in a list. The table, you can think of the table as like a list, right? And again, it can be dynamically generated through the code, or you can, probably easier to dynamically generate it. What else? We'll have a home screen. We'll include the National Park logo, blah, blah, blah. Then there'll be a section of buttons. I think we looked at the one from Iceland. Did you see the one from Iceland? I think I showed you the Iceland app. Okay, so we'll have some buttons with like some camping info and general info. We'll have a second button go to photos of the park and blah, 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 in a grid layout. And then we'll make sure that it connects to the internet. We'll have, again, we already did that before, but we'll review that. Today in the code, they do talk about the URL attribute, right? Making a URL object that you put the string of the address into. They talk about that in our lecture today. And then, of course, the map we have to learn. There's a video here of how to do the map already. If you're ready and ambitious to jump into doing the map right here, is how to do what we call map kit right here.
Code it out.
Yeah, this is a video of a guy talking about how to do the map. Basically, I follow the same video too. My lecture will be like that. Okay, so we'll learn how to do that as well in the map. So let's get started. Again, I'm mostly going to talk about chapter 3 in the book here. Let's jump to the first page of chapter 3. So again, chapter 3, we'll talk about optionals right here. Then we're going to jump again, like I said, to chapter 4 here, and there's one that's for table views. Table views, okay? And this is how we'll build the actual. So you can see what the table looks like, right? It's just a big table. You can have artwork in there. You can have text. You can have different size text. You can have the main text and a description. And you can have all kinds of different. It just depends. So they talk about how to do that. It's a very useful because the reason why the table view is good is you have a constant navigation at the top. That's most apps that you see on the iOS with the back button, right? Okay, that's what that are all made in the table view, or what's called table views. But first, let's get to chapter 3. Let's just talk about that. We've got to keep learning a little bit of code and why things are happening. And this first talk is about the question mark and the explanation point. These are called optionals, okay? It's a way of describing content either if it has something or it doesn't have something. And so they call it, Swift uses unique syntax called optionals to represent when a value may or may not contain any data, right? Maybe you have a value that's going through your code that doesn't have anything in it yet. What type of value is that as well? And you need to learn the difference. In this lesson, you'll learn to use optionals to properly handle situations when data may not or may not exist. Okay. Optionals are useful in situations where a value may or may not be present. An optional represents two possibilities. Either there is a value, you can use it, or there isn't a value at all. Imagine you're building an app for a bookstore that lists books for sale. You have a model object book type that has properties name and publishing year. But of course, you might not know what publishing year is. So you'll see here you got a struct, a book. First property is a name, which is a string. Publishing year is an integer, right? That would be the year the book is published. And you can see the example here. So we got Harry Potter, second Harry Potter, third Harry Potter, let book be blah, blah, blah. And so books would be all these together. So far, so good. Now imagine you're building a screen that shows a list of books that have been announced but haven't yet been published. How might you initialize these books without a published date? What do you assign to the publication year? And again, they have another building an example here, but of course you can't put a 0 in there. 0 isn't accurate because it would mean the book is over 2,000 years old, whatever. Again, the current year isn't accurate either because it may release next year. There's no known launch date. Nil. Okay, you might have heard of the word nil before. It's basically the absence of value. Okay, it's not 0. It just means the absence of value. Okay, nil represents the absence of value or nothing because there's no publication year yet. Publication year should be nil. And so they show an example of assigning nil. That looks better, but the compiler throws an error. At all instance properties must set during initialization. You can't pass nil to the publication year parameters because it expects an integer value. Where did the integer value come? Here, remember that? That's where they initialized it, right there, right? Okay, so in this case, you can't put nil in there because it wants an integer or a number, right? Optionals solve this problem by providing a wrapper around a value that may exist. You can think of the optional as a box that, when opened, will contain either an instance of the expected type or nothing at all. Every type has matching optional types, which you declare by adding the question mark. You've seen that question mark before in your code, and you're wondering, why is that there? Well, it's just there because it's a holding spot. It's, hey, this could have value, it's a holding. It's a way of holding data somewhere that might not have data yet. That's the term, yet. After the original name. In this case, you need to update the type's annotation on publication year property to this, the optional value. So when you're declaring this property here, you put the question mark there. Then as it cascades through your code, you can have an absence of value is what they're trying to say for the publication year. Note that you can't create an optional without specifying the type. Consider what would happen if you tried to let Swift infer the type, right? Because remember, Swift infers a lot of things for us sometimes, right? Is this a string, you know, there? But for this optional, it could be a problem. Consider what would happen if you tried to let Swift infer the type. In this example, type inference will assume your variable is non-optional. In this case, a 404 error, right? Could be an integer, or it could be a string, maybe. I don't know. In this example, type inference doesn't have any information to determine the data's type if the data isn't nil. So you'll notice that an error, no type specified. For this reason, a safe method to specify the type when creating the optional. Take a look at the following correct approaches to the integer optional. So again, they have a variable with the server response is an integer, and it's equal to 404 error. And then again, you could have a nil for the integer as well. How do you determine whether or not an optional contains a value? How you access the value? You could begin by comparing the optional to nil using the if statement. If the value is not nil, you can unwrap the value using the forced unwrap operator or the explanation point. You've seen that one before in your code, right? What that's doing is you're telling it, hey, to make sure you do something, right? If publication year is nil, let actual year equal publication year, print actual year. Again, it's saying you must have something in here. If you skip the comparison of the optional to nil and you force unwrap an optional that doesn't contain a value, the code will generate an error and crash when you try to run it. It seems like a good practice to compare an optional to nil before attempting to use the contained value, but it also feels somewhat risky. As you recall, safety is one of the primary goals of the Swift, and safe language should elevate programmers' errors before the code is executed. With optional binding, Swift unwraps the optional, and if it contains a value, assign the value to a constant that's safe to work with. This approach eliminates the need to continue working with nil. Okay, again, let's read this again. It seems like a good practice to compare an optional to nil before attempting to use the contained value, but also feels somewhat risky. As you recall, safety is blah, blah, blah. Okay, with optional binding, Swift unwraps the optional, and if it contains a value, assigns the value to the constant that's safe to work with. This approach eliminates the need to continue. So basically, you have an if statement that's comparing. Does it have value? If it does, then use it. If not, just ignore it. I guess if that's the word, ignore. If some optional has a value, the value is assigned to the constant name and is available only within the bracket or braces. Take a look at how optional binding works on the previous book example. So again, they're using the if statement here, and they're having a constant, right? If this constant, unwrapped publication year, equals the book's publication year, print the book was published in, and then of course it can use this value, right? It can use it there. That's the if statement, if it has value. If not, it can pass it by. Does that make sense, the if statement? So the if is here to see if this actually has value in it. Just like other if statements, you can add an else clause as well. If this has value, then let's do this. If it doesn't have value, well, do this. It doesn't have an official publication date. Yep?
So the idea is kind of the default values in a way?
Yes, I would say.
That's what the if loop is for. I guess it's not really an if loop. It's more
No, it's not really looping at all.
Yeah,
it's
it's
just
just
asking, does this have some value to it? If it does have value, then let's put the year in there. If this doesn't have value, or nil in this case, you don't have to use nil anymore. That's why we're using the if statement. That's what they're trying to say. Is the nil is a good idea, it works, blah, blah, blah. But we really don't need to use it because you can use this if statement to compare this, right? And then if it doesn't have value, then of course the publication date wouldn't be there. You can put this in the message right there. That's what you're trying to say. So you're comparing. You've seen the if statement before like that. Swift comes with many functions that return optional values. Consider the example where you have a string whose value is set to 1, 2, 3. You can see here that the string could be converted into an integer. So let string equal 1, 2, 3. Let possible number equal integer string. But what if the string can't be converted? Right? Cynthia can't be a number. Cynthia is not a number, right? Let possible number equal integer string. Swift infers possible number to be an integer type because the integer string initializer may or may not be able to successfully convert the string into an integer. If string can be converted into an integer, possible number will hold that value. If it can't, possible number will be nil. So again, it's looking at what this could be and then using the nil in the place if it doesn't match it. If you want to write a function that accepts an optional as an argument, simply update the type in the parameter list. Consider this print function that accepts the first name, middle name, last name. This allows middle name to be nil since not everybody has a middle name. Again, look at the question mark there. So adding the question mark is what they're trying to talk about. Will be able to cascade your value through your code. Same is true. So again, the middle name has the question mark there because not everybody has a middle name. The same is true for a function that returns an optional. Just update the return type. For example, a website URL returns the text from the page. The return text is optional because the URL may not work or may not return any text. Again, you might see this. We'll be looking at URL. Okay, the URL is mostly a string, which would be an address, right? But it could cause a problem, and you might have an error. So again, there's a function called text from URL with a URL, and then which is a URL, and then you'll see that it is a string, but of course it has the question mark here at the end, so it could be a value of nothing as well. which then this would have nothing in it. Any initializer that might return nil is called a fallible initializer. Early in this lesson, you saw how the integer initializer attempted to create an integer from a string and return a nil if it was unable to convert the string. For greater control and safety, you may want to create your own fallible initializers and define a logic for returning an instance or a nil. Consider the following definition for a toddler. So again, we have a struct, and they're making a toddler. That toddler can have a name as well, which is a string, and it can have how many months old, which could be an integer in this case. Okay. But again, in this example, the toddler must be given a name as well as an age in months. However, you may not want to create an instance of the toddler if the child is younger than 12 months or older than 36 months. To provide this flexibility, you can use the integer with the question mark to define a fallible initializer. The question mark tells Swift that the initializer may return nil, and that it should return an instance of the type toddler. Within the body of the initializer, you can check if its given age is less than 12 or greater than 36. If either one is true, Swift will return a nil instead of assigning a value to the age. So again, they're using the this INIT with a question mark, right? Again, you got a string for a name, months old. Okay, and then they have a comparison. If the months old is less than 12 or months old is greater than 36, return nil, else put the values in there, right? You would put the name as the name and the months old, the months old. Does that make sense? When you use a fallible initializer to create toddler instance, an optional will always be returned. To safely unwrap the value before proceeding to use it, you can use optional binding. So again, to add to the what was going on there, you can let the possible toddler equal toddler, of course, has a name, months old 14. If the possible toddler, and of course they print the name of the person is age old, else the age. So it's just like the example from before, right? With the if statement that was there, right? You're testing to see, does toddler, the possible toddler.
So we can substitute the if condition by just putting a question mark after the possible toddler, right? That would accomplish the same. Because if the initializer, the init,
Yes.
it's returning an optional already, right?
Yes. You mean where? Here?
Yeah, first line.
Yeah.
The let possible toddler. If I just put a question mark after the possible toddler, then the if condition is not needed, right? Because it will automatically take care of that.
Yeah. I understand what you're saying, yeah. Then again, they talk about optional chaining, which you have more than one. You'll notice here, is it possible for optional values to have optional properties, which you think of a box within a box? These are called nested optionals. In the following example, note that every person has an age and may have a residence. A residence may have an address, but not every address has an apartment number. So you'll see the address, so on. So the the residence could have a question mark, address could be a little bit different. We can leave it. And so you'll notice it's just they're adding the question mark where it needs to change. Okay. So this is an optional which is inside this optional which is inside this optional, if that makes sense. Think of them grouping them together, right? That's what the optional chaining is called. Unwrapping nested optionals can require a lot of code. In the following example, you checking an individual address to find out if he or she lives in an apartment. To do this, a given person object, you must unwrap the residence option, the address option, and the apartment optional. Using if let syntax, you have to do quite a bit of conditional unwrapping. So again, if the residence, okay, has a resident, right? If the resident has a resident, then if that address has an address, then let if the apartment number has an apartment number, then print the apartment number. So again, do you notice it has cascading with if statements there? But there's a better way to do this, of course. Rather than assigning a name to every optional, each property can be conditionally unwrapped using a method called optional chaining. If the person has a resident and the address has an apartment number, and if the apartment number can be converted to an integer, you can refer to the number using the apartment number as below. And here they kind of, you can see it's kind of put together. They still use the residence address and the apartment number, but instead of having if let, they put it together. That's all.
Simplified it by not using those two ifs, right?
Yeah, then you don't have to use the two extra ifs there. You're just putting them together. When chaining together optionals, a question mark appears before each optional in the chain. If a nil value breaks the chain at any point, the if let statement fails. As a result, no value is assigned to the constant, and the code inside the braces will never execute. In this example, person has a resident with the address that includes an apartment number, so the print statement will execute, right? Implicitly unwrapped optionals. An object cannot be initialized until all of its non-optional properties are given a value. But in some cases, particularly with the ISO development, some properties are nil for just a moment until the value can be specified after initialization. For example, you use the interface builder to create outlets so that you can access particular pieces of the interface in code. Again, the class is the view controller. We've been using view controller, UI view controller. Okay, if you were a developer of this class, you would know that anytime a view controller is created and presented to the user, there will always be a label on the screen because you added it to the storyboard. But in iOS development, the storyboard elements aren't connected to their corresponding outlets until after initialization takes place. Therefore, label must be allowed to be nil for a brief moment. Again, label. Here's the explanation point, right? What about using the regular optional with the question mark, right? For this type, the standard optional will require if-let syntax to completely unwrap the value, providing a safe mechanism for data that may not exist. But you know that that label will have a value after the storyboard connects to the outlet. So unwrapping an optional that isn't really optional feels cumbersome. To get around this issue, Swift performs the syntax for implicitly unwrapping optionals using the exclamation mark instead of the question mark. As the name suggests, this type of optional unwraps automatically whenever it's used in code. This allows you to use label as though it were an optional while allowing view controller to be initialized without it. So again, they're using the explanation point as another way of holding the value for optional. Explicitly unwrapping optional should be used in one special case when you need to initialize an object without supplying the value. But you know you'll be giving the object a value very soon afterwards. It might seem convenient to reach for implicit unwrapping options to save yourself from using if-let syntax, but doing so you'll remove one of the most important safety features from the language. Okay, you ready? Who's ready for the test? Which of the following declares a double with a value of 4.2 that can be set to nil at a later date? Which of the following declares a double? Okay, we got a double here with a value of 4.2, but then it needs to be set nil at a later date. They need to change it. You think C or D? C? Very good. Why is that? Because it has a variable, right? It needs to change. Right? Yeah, it needs to change later on, right? That's what they said, change. Oh, well, I'm sorry. Oh, here it is. There we go. What is the overall purpose of the following code? If height with the exclamation point equals nil. Verifies height has been initialized. It has a value of nil. Forced unwrap height to access the value. The exclamation point, forced unwrap. Uses optional binding to safely extract a value from height. Checks if height contains a value but does nothing after it checks. Which one? D. There you go. Okay, again, it's checks the height. Does it contain a value? But of course, it could be nil. Which of the following code snippet uses valid option binding syntax? Valid optional binding syntax. See? With the exclamation point here? No. This one is equal to if let dog name is equal to owner dogs first. If let dog name equal owner dot dog dot first. What's it? Mm-hmm. Which one? A, okay. There you go. How come? It says optional binding syntax.
It should have some question marks, right? Owner, dog.
Well, it's using the if let dog name equal owner's dog first name. It's putting these together. Is that what you're trying to say, Jennifer?
Well, D has the double equal, which means there's no option.
D?
No, it's not D. It is A, but D has, no, it's A.
I know. I'm just.
It's A because I checked them all and A was the only one that came free.
There you go.
Yeah, why isn't it C?
I'm trying to figure it out myself. If dog name equal owner, dog. I would think it would be this one as well. I don't know. I don't have an answer to that. Let's move on. Last one. Is the following initializer a valid fallible initializer? Struck, report card, variable student is a string, variable average GPA is a double. Initialize student name string, GPA is a double.
B.
If student name equals student name self average GDP. Yes, the syntax is correct and could return nil. Well, I guess they probably have to have a name and a GPA even if it's 0 or something, probably, don't they? Yes, it's valid, but probably should be marked as fallible since it never returns nil. No, the initializer never returns nil. Which one?
B.
B? There you go. Congratulations. You did well. Typecasting, and this is very short. I'm going to do this one other one reading with you. It's 5 screens. It's all. It's like really short, I'm telling you. Whenever you work with data, the type plays a crucial role. For example, if a function returns an integer, you know you can use its value in a mathematical expression. But what if the type information isn't very specific and you need to inspect the data more closely to determine how to use it? In this lesson, you'll learn some data can only be expressed using a broader type and how you can test for specific kinds of data before using it. You got as, any object, conditional cast, downcasting, typecasting, type the inspection. Suppose Brad's job is to visit the homes of clients and take care of their pets. When he arrives at each location, he performs a different task depending on the type of animal. If the pet's a dog, he takes it for a walk. If it's a cat, he changes the litter box. And if it's a bird, he cleans the cage. The Swift functions determine the type of data to be returned. Since the function can't return a dog, a cat, and a bird, the best it can do is return the parent type of all 3 animals. So let's look. So it makes a function called getClientPet, okay, and it's going to have an animal. Let pet equal getClientPet, okay, so we got, a pet. Unfortunately, this type is too broad to be useful to Brad without knowing the specific animal type. He could accidentally try walking the bird, cleaning the dog, litter box, blah, blah, blah. Consider the following valid function with dog, cat, and bird parameters. So instead, you have a function, a walk. Okay, so then it has a dog, print, walking dog. Then there's a function clean litter box. You got your cat, clean the box, cat size, litter box. I don't know what size the cat size is, box size is. Function clean cage, bird, print, remove bird, feathers at the bottom. Brad needs to be able to access the version of pet that's one of the subclasses of animal. You can use this as operator to try and downcast the value for a more specific type and store it in a new constant. This operator is known as a conditional cast because it casts, for instance, to a specific type if it's possible to do so. If you use the if-let syntax to check the condition before converting the type. Again, this is the as right here is what they're talking about right here. Okay. So it's basically a way of saying if it's this, then do that. If it's that, then do this. And if it's this, then do that. Right? So again, if you look over here, it makes a function here. Right? Walk, so on. So if we go over here, let pets equal all client animals. For pets in pets, okay, so pet in pets, which is all client animals. If it's a dog, then the pet, let the dog equal pet as a dog. I don't know why you have a walk dog. Else if it's cat, then, so they're talking about the as, okay? So they're using the as to look inside the animals to find out which animal is what, if that makes sense. Because that, you know, it's looking inside all client animals to see, right? Well, it's actually looking at pets. Now Brad can be sure he's walking the dog, cleaning the litter box, and so on. There's also a form of the typecast as operator. This version of Gwyn, this one has explanation point, right? Instead of the question mark. This version will force the downcast to a specific type, but if you specify an incorrect type, it will crash your program, just as it does with the forced unwrap as an optional. Imagine Alan has one pet, a dog, and he goes to pick it up from the pet store. A fetch pet for customer string function may return the animal type. Let Alan's dog equal fetch pet for Alan. Alan's dog is referred as an animal type. When you know that the return object will be more specific type, you can use the as operator to cast the value immediately. Just like it did with the explanation point with the label, right? Remember the label? Right? Let Alan dog equal fetch pet for Alan as a dog, right? Forcing it to be part of the dog. When you dive into building apps, you'll discover that when working with UIKit, the APIs can return very generic objects such as the view controller. But as a developer of your application, you know that the specific type should be, for example, if pressing a button on the view of the first view controller always presents a second view controller, you can force the downcast of destination to second view controller within the prepare for segue function. This function is called whenever you present a new view controller. And we've seen that before when we were doing the screen, right? Prepare. So again, you have a second view controller, function prepare for segue, storyboard, sender, any. Let the second view controller equal a segue destination as a second view controller names, Peter, Jamie, whatever. Use the as with the explanation point only when you are certain that the specific type is correct. Of course, it's going to be what? A view controller, right? You've learned that arrays by default are set to handle a specific type, such as integer, strings, or animal. Homogeneous collections are very simple to work with because you know the type of every instance within them. But what if you want to work with non-specific types? Swift provides two special types, any and any object, any. Any, as the name implies, can represent an instance of any type. And you see this when you're making the connection, right? Remember when we were doing the connection to the action, right? And was it a button or any in there, right? Because there's the any option in there, right? That's what they're kind of talking about. What does that any object be? What is that any object, right? But what if you want to work with non-specific types? Swift provides two special types, any and any object. Any, as the name implies, can represent an instance of any type, string, double, function, or whatever. Any object can represent any class within Swift, but not a structure. Here's an example of array that can hold any type of instance or any. Variable items, of course, it has any, equals 5, bill, 6.7, dog, and because the array above can include anything, there's no way to guarantee the type of any item. For example, if you want to use items 1, which of course is bill, to access the first item in the following array, it will return value of 5, which is of course the first item. With the any type, go ahead and use the first value, first item, as an integer. You'll use the as operator. Again, they're talking about, if you look up here, you got a variable items, which could be any, and then they have 5, which is of course bill, and then this one as well. This could be an option. Variable items, any, by, bill, whatever, blah, blah, blah. If let first item equal item 0, which is this item here, as an integer, print first item plus 4, which again would be 9, because 5 plus 4 is 9. Although any can be used just like any other type, it's always better to specify about the type you expect to work with. Before using any or any object your code, make sure you need the behavior and capabilities these special types provide. Again, we have a quiz. Let's do the quiz. If a variable can be set to any given structure, what is the variable type? Any? When you conditionally downcast from one type to another to store the values in a constant, which combination of keywords is used? Check all that apply. Do you remember? You're downcasting, right? A? D? A and D? Very good. When it's appropriate to use the as operator, of course, then it must have a value, right? When you need to unwrap an optional, when you need to convert the value to any type, when you need to downcast from one type to another on a condition that the type is valid, when you need to downcast from one type to another and you can guarantee the type is valid. B or D? Huh? D, yeah. I was going to say D because it needs to be valid. Okay, let's jump to starting the park thing. Okay, we just wanted to talk about some. I'm going to stop this here. So let me pause this recording here.